Hello everyone. Welcome to the mini lecture on electromechanical control technology. Today, we'll learn about the I/O configuration of a motion control card. Our lesson will cover the following 4 main topics. Through this lesson, you should be able to identify and describe the basic types and functions of the I/O ports on a motion control card and independently complete the I/O port configuration, including physical connections and software setup. I/O ports, or input-output ports, are essential channels for signal exchange between the motion control card and external devices. Properly configured I/O ports enable diverse and intelligent motor control. Next, let's learn about basic knowledge of I/O ports. The I/O port, short for input-output port, is an interface on the motion control card used for signal transmission with external devices, such as sensors, actuators, and indicator lights. Input ports receive external signals, like those from sensors, while output ports send control signals to external devices, such as starting a motor or lighting an indicator. Next, let's talk about the importance of I/O configuration. Accurate I/O configuration ensures reliable signal transmission between the motion control card and external devices, enhancing system stability and reliability. Additionally, flexible I/O port configuration enables diverse motor control methods, such as automatically adjusting motor operation based on sensor signals, or using indicator lights to display motor status. We'll next learn about steps for I/O configuration. 1. Determine I/O port requirements. Based on the motor control system's functions and the needs of external devices, determine the required input and output port types and quantities. 2. Consult the control card manual. Review the manual to understand the distribution, functions, and electrical characteristics of the I/O ports on the control card. 3. Physical connection. Based on the requirements and guidance in the manual, use appropriate cables and connectors to physically connect external devices to the control card's I/O ports. 4. Software configuration. Using the control card's programming software or configuration tool, set up the I/O ports in software. This includes setting the port mode, input-output, signal type, digital/analog, filtering parameters, etc. 5. Testing and verification. After configuring the I/O ports, conduct necessary tests. Check the accuracy of the I/O configuration and verify stable signal transmission. We'll next learn about example of I/O configuration. To better understand I/O configuration, let's look at an example. Suppose we need to configure a motion control card to control an automatic door system. In this system, we have an infrared sensor for detecting the approach of a person and a motor driver for controlling the opening and closing of the door. Demonstration. 1. Determine I/O port requirements. We need one input port to receive the infrared sensor signal and one output port to control the start and stop of the motor driver. 2. Consult the control card manual. Locate the input and output ports that meet our needs, and understand their electrical characteristics and connection methods. 3. Physical connection. Connect the infrared sensor's output to the control card's input port, and connect the motor driver's control terminal to the control card's output port. 4. Software configuration. In the programming software, set the input port to digital input mode to receive signals from the infrared sensor, and set the output port to digital output mode to control the motor driver's start and stop functions. Configure filtering parameters as needed. 5. Testing and verification. Simulate the approach and departure of a person to check if the infrared sensor correctly triggers the control card and if the output port accurately controls the motor driver's start and stop functions. Through today's lesson, we explored the methods for configuring the I/O ports of a motion control card, including basic knowledge of I/O ports, the importance of configuration, and configuration steps. I hope everyone can master these concepts and apply them flexibly in real-world projects. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.